going to start off by graphing the sine function. The sine function is graphed in a period of 2 pi. And this would be 3 pi over 2, pi, and pi over 2. So it would be here, 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 and here. This is my sine function. And of course, it would continue in this direction. It would just continue the same pattern. And also this way as well. It goes on forever. Now, if I were to do the horizontal line test, it definitely fails it. It crosses more than once when you draw a horizontal line anywhere along the sine function. So as it is not invertible. So in order to get the inverse, I must restrict the domain. So I'm going to restrict the domain from negative pi over 2 to pi over 2. So notice when I restrict the domain, it will now pass the horizontal line test. If you draw horizontal lines, each of those lines will only cross one time. So if I restrict the domain from negative pi over 2 to pi over 2, I can now find the inverse of sine. My range is -1 to +1. So now that I restricted the domain, I can now find the inverse of sine. Now, the domain and the range will be these reversed. So my domain of the inverse would be -1 to 1, and my range would be negative pi over 2 to pi over 2. So let's get the points and graph the inverse sine function. And of course, another way to say inverse of sine is arcsine. These both mean the inverse of sine. So looking at my original graph over here, at negative pi over 2, the y value is -1. At 0, the y value is 0. And at pi over 2, the y value is 1. So to get the inverse of sine, I'm going to swap the x's and y's. Now let's plot the points. So I'll say -1 is here, +1 is out here, this is 0, and I'll say pi over 2 is up here, and negative pi over 2 is down here. So -1, negative pi over 2 is there, 0, 0, and 1 pi over 2 is there. So this is what your graph would look like. And if you were to use a graphing calculator or use an online calculator, this little segment is what you would find if you type in arcsine or inverse of sine. That is exactly what you will get, that little piece. And of course, if you graph sine in a calculator or online, it will go on forever, just continuously, okay? So the important part that I want you to get is we restricted the sine function from negative pi over 2 to pi over 2. That means if you're looking at a unit circle, we went from negative pi over 2 all the way to here, pi over 2. That means the inverse will only exist in the first quadrant and in the fourth quadrant. That is the only place where the inverse of sine will exist, because that's where we restricted the domain. So let's fill this out. We said the domain was -1 to 1 for the inverse, and the range was negative pi over 2 to pi over 2. Right? That's what we had right here. Okay, and it only exists in the first quadrant and in the fourth quadrant. These are the only locations where the inverse of sine exists. Yesterday, we talked about arcs cosine. And we said the domain was -1 to 1. Do you guys remember what the range was? Yep, 0 to pi. So it was only in the first quadrant, and the second quadrant is where the inverse of cosine exists. Now, let's talk about the inverse of tangent, also known as arctan. Okay, to begin, I'm going to graph the parent function of tangent. And if you remember from the unit circle, tangent does not exist here at negative pi over 2 because the coordinate is 0 over negative 1. And you can't put y over x here. That would be d and e. You have an asymptote there. And it also does not exist at pi over 2. So we're going to go from here to here. So this is negative pi over 2. This is negative pi over 4. This is pi over 4. And this is pi over 2. There were asymptotes right here because that is where tangent is undefined. This is your inflection point, and these were your other 2 points. So this is what the tangent parent function looks like. And of course, just like all the other trig functions, it just repeats itself. So you would have another one as you went around the unit circle. You would just continue. However, if you continued the tangent function, it would not pass the horizontal line test. That means I want to restrict my domain, and I'm only going to graph the first period. I'm only going to graph one period of tangent. So I'm only going to look at the x values between negative pi over 2 and pi over 2, so that it will pass the horizontal line test. Do you guys notice that I did parentheses instead of brackets? Why? Good, because there's asymptotes here that doesn't exist. Good. Now my range is all real numbers. So that means for the inverse of tangent, you just swap the domain and range. So that means the domain for the inverse would be all real numbers, and the range would be from negative pi over 2 to pi over 2. And those are also parentheses because it does not exist at negative pi over 2 and pi over 2. It's undefined at those locations. So let's go ahead and graph the inverse of tangent. So in order to do so, let me get some points. At negative pi over 4, I'm at negative 1, 0, 0. And at pi over 4, I'm at positive 1. So to get the inverse graph, I'm going to swap x and y. Okay, we have our points. Now we're going to plot it. I'll say here is negative 1, 0, and 1. I'll say right here is pi over 4. And down here is negative pi over 4. Okay, so my first point. Oh, I put a 2. All right, so negative 1, negative pi over 4 is there. Here's 0, 0. And then here's 1 pi over 4. And remember, guys, there were asymptotes at negative pi over 2 and pi over 2. So I'm going to put an asymptote here at pi over 2. And an asymptote right here at negative pi over 2. That's where your asymptotes are. So this is what the inverse graph will look like. The most important thing. Where does tangent inverse exist? Well, if you remember, you restricted the domain here at negative pi over 2 and at pi over 2. So it only exists from here to here. In the first quadrant and in the fourth quadrant is where the inverse would exist. So that means it only exists here in quadrant 1 and in quadrant 4. There and there. And this was your domain, and this was your range. So the important thing to know, the inverse of cosine exists here. The inverse of sine exists in the fourth quadrant, and so does the inverse of tangent. And they all exist here. Nothing exists in the third quadrant for the inverses. It's either the first quadrant, the second quadrant, or the fourth quadrant. So, knowing where they exist, let's go ahead and start evaluating. All right, here's your first problem. What is the answer? This is what you should be asking yourself. Whenever you see the inverse of sine, you should be asking, at what angle does sine equal square root of 3 over 2? Where is it? Pi over what? 3, pi over 3. Next one. You should be asking, where does sine equal negative square root of 2 over 2? Those. All right, class. Raise your hand if you got 7 pi over 4. That is all wrong. It is not 7 pi over 4. Don't feel bad. Every class says it. Let's talk about it. You guys said 7 pi over 4 because that is right here. That's the angle 7 pi over 4, and the coordinate is square root of 2 over 2 and negative square root of 2 over 2. So you chose this one, right? This is the angle where the y value is square root of 2 over 2. This is not your answer because remember, the important thing I needed y'all to remember is that sine exists only in this quadrant and this quadrant. And this is your range right here. So let's look at the picture that I drew you. 7 pi over 4 is right here. But I restricted the domain to be between negative pi over 2 and pi over 2. So where is sine negative square root of 2 over 2 within the restriction that I gave you? Exactly. Did you say negative pi over 4? Okay, so it should be negative pi over 4. Because you're looking between negative pi over 2 and pi over 2. So this location is negative pi over 4. This location is positive pi over 4. So this should be your answer. Next one. Try it. All right, let's talk about it. I like the thinking that's going on. So let's go to the unit circle. I know that the inverse of tangent exists either here or here. But I know that everything in this quadrant is positive. So it's not going to be up here. It has to be down here. And this is the angle negative pi over 4. And the coordinate at negative pi over 4 is square root of 2 over 2 and negative square root of 2 over 2. Now, if you remember, tangent is always y over x. So that's negative square root of 2 over 2 divided by square root of 2 over 2, which is what, guys? Negative 1. So when it says, the question you should be asking yourself is, where is tangent equal to negative 1? The answer is negative pi over 4. So that means this whole thing, you can just write pi over 4. But you still have sine on the outside. What is sine? Oh, sorry, negative pi over 4. What is sine at negative pi over 4? This value. Negative square root of 2 over 2. So your answer is negative square root of 2 over 2. Good job. This next one. You know from the unit circle that at pi, cosine is negative 1. That value. So then the inverse of tangent of negative 1 is right here at the angle negative pi over 4 because the coordinate is square root of 2 over 2 and negative square root of 2 over 2. And when you divide those, y over x, you get negative 1. So the answer is negative pi over 4. All right, so for this type of problem, we're going to use a triangle. I'm going to call this theta. And I know that cosine is adjacent over the hypotenuse. So if I do Pythagorean theorem, I can figure out this missing side. So 5 squared plus, or minus 4 squared is 25 minus 16, which is 9. If I do the square root of 9, I get the missing side of 3. So the information I can take from this triangle, based off of what they gave me, is that arcsine is what? What would arcsine be? Yes, 3 over 5, because it's opposite over the hypotenuse. So for the same angle, we're talking about the same angle right here. The arcsine of that angle is 3/5. I'm pulling all of this information from the same triangle. That means if I wanted to do sine of that same triangle, I get 3/5. Sine and arcsine cancel out. And if you want to know why they cancel out, let's take another example. Let's do sine and then sine inverse of square root of 2 over 2. So you should ask yourself, where is sine equal to square root of 2 over 2? Pi over 4. So that means this is just pi over 4. Well, what is sine of pi over 4? Square root of 2 over 2. So your answer is just square root of 2 over 2. So whenever you have sine and the inverse of sine, it cancels out. Just like if you have cosine and the inverse of cosine, they cancel out. Inverses, yep, tangent, any inverse, they cancel out. So we had this example. I want you guys to challenge yourself with this example. Ready, go. All right, y'all did a lot of good thinking. Let's do a triangle. Okay, so remember, tangent is the opposite over the adjacent. So that means this is W on the opposite end and 2 on the adjacent end. So to find out the hypotenuse, you have to do W squared plus 2 squared, which is W squared plus 4. And then you take the square root of that. So then that is W squared plus 4. Okay, so if I want to cancel out sine, I'm going to find the inverse of sine using the exact same information from my triangle. To get sine, I do opposite, which is W, over the hypotenuse, which is square root of W squared plus 4. Those inverses cancel, so this is my answer. Yes. Okay, so let's go ahead and rationalize this. Does everyone understand how I got this part so far? Okay, great. Now let's make our answer presentable. Presentable. We don't want a square root in the denominator, so I'm going to rationalize this. I will multiply by a ratio of 1. So this is square root of W squared plus 4 times square root of W squared plus 4. I'm just multiplying by 1. So this will become W square root of W squared plus 4. And this will be W squared plus 4. And that's your final answer. Okay, so for this next problem, you're going to need a calculator. So you can either use Desmos or you can use a yellow calculator. All right, so guys, using a calculator, how do you think you're going to figure out what this is, what theta is equal to? I want to know what angle that is. How do you get rid of sine? Multiply by what? The inverse. So those will cancel out and multiply this side by the inverse. So that means to get theta, you need to type into your calculator the inverse of sine square root of 13 over 7. So if you type this into your calculator, it will give you that angle measure. Now, let me draw a little picture of what you guys have on your calculator. This is y'all's little screen, and these are y'all's little buttons, right? Y'all have buttons here. Up here on your screen in the top right corner, if you hover over it, it might say rad, or it might say, that stands for radians, or on the top right corner of your screen, it might say degrees. Hover over it and click it, and it will change. Can you guys see that? Good, it's in radians. Now give it to me in degrees.
How do you know?
You hover over, put your little arrow, hover over it, and click it. So what degree is it? 31 degrees? Perfect.
Oh, you should read.
Also, guys, on your calculator, this is the control button. Right under it is a trig button. Click the trig button to click whatever trig function you want. Okay, so did everyone get 31 degrees? Perfect. Let's do another one just to practice. How about find me tangent of -4/5? Give me that. What is the angle equal to? And I want it in degrees. Yes, round to the tenths. Actually, round to the thousandths.
0.659.
Okay, I want y'all to round to the thousandths place. Thousandths. So you take the inverse, tangent inverse, it cancels out. Tangent inverse. This is what you type into your calculator. What'd you get?
I got -38.66 because it was 659. So
659.
and then there was an 8. So I rounded.
Oh, okay, good. So -38.66. I'll take that. Degrees. Nice.